Hey guys, so today we're going to be doing another energy question, but this time it's going to be about gravitational and kinetic energy. Alright, so before I tell you about the question, I want to tell you a bit about the law of conservation of energy. This law states that no energy can be created or destroyed, but can only be transformed in two forms: potential, which is stored, and kinetic, which is moving. No external force, such as friction, can be involved, as friction is released in heat. The law of conservation of energy breaks down into the total energy in the initial equals to the total final energy. But before we begin, let me tell you a bit about potential energy and kinetic energy. Potential energy is stored energy. Kinetic energy is moving energy. But what does this exactly mean? So potential energy is the energy of an object that is at greater height and can fall with a kinetic energy. So for example, if there is a ball on top of a building, just being held there, it has a potential energy to fall down. This potential energy is caused by its mass, the gravitational pull of the earth, and its height, while kinetic energy is the ball moving down. This is the mass and velocity of the ball. Okay, so now let's jump into the question. The question is that a ball that weighs 5 kg falls off of a 100-meter tall building with an initial velocity of 0 meters per second, so it is at rest. At the halfway down point, what is the ball's final velocity? So let's see what we're given in this question. In this question, we are given the mass of the ball, the initial velocity, and the total height. What we need to find is the final velocity. Alright, so let's jump into this. How are we going to start this? Total final energy. So the way we're going to break this down is first find the midpoint. So the midpoint from 100 meters is 50 meters. So now we know that the initial height is 100 meters and the final height is 50 meters. Now we can start off with setting an equation, which is the sum of all initial energy equals to the sum of all final energy. Initial energy can be broken down to potential and kinetic in its initial and final state. So potential energy has a formula of mass times gravity times height, as shown over here. We have broken this down into both final and initial values. So now when we're going to start this equation, we know that the initial velocity is 0, so we can just cross this out and say it's nothing. Now we can start rearranging the formula to bring the potential final energy over to the left side. Now we want to isolate the velocity, so we'll continue to bring over 1 divided by 2, which is multiplying with m, which is multiplying with velocity squared, over to the other side, meaning it will be dividing now. Now, and the last step of reorganizing this is to bring over the power of 2. The other side of this is the square root. Now we can begin to plug in our values. We can plug in the mass to be 5 kg, the gravitational pull to be 9.8, and the initial height to be 100 meters. Minus 5 kg multiplied with 9.8 meters per second squared, the gravitational pull, multiplied with the final height, divided by 1/2 multiplied with the mass of 5, and square root all this. If we continue to simplify this, our final velocity will be 31.3 meters per second. And this is how you find the final velocity of a falling ball. Well, that's all for today, and have a good day.